MapReduce? Small number of people. Okay, good. We know where we're starting from. MapReduce is 10 years old. MapReduce is a technique which is 10 years old. It was invented by Google for running big databases that people could use for running searches on. It was used by Facebook to build Facebook. And it's basically just being able to query big databases fast on a cluster. Google have a 2004 paper. If you want to be academic about things and publish papers, but if you want to get rich, just use the information and apply it. Hell's teeth. I did have, for those of you who don't, let me see if I've got the right, presentation up. Okay. Okay, learning about Spark is it's a teach yourself exercise. We're not going to teach you as if you were back in primary school, where I stand up in front of the class and tell you to write things down and you give them back to me. It's about teaching yourself. We will give you the tools that allow you to teach yourself the technology. You will find at that link an IBM video which allows you to understand how MapReduce works. You take a problem, you break it up into small parts, you distribute it out to the servers, you do a small amount of processing. Instead of moving vast amounts of data to a processor, you move the program to the fragments of the data. You analyze the data on the fragments, you then collect the results back in together. The first stage is called mapping, the second phase is called reduce. There are lots and lots of information. All these slides will be available online, so if you haven't got time to write this down, we will show, at the break I will get the video up because I have it on my PC, and I can show you the video. It's 2.5 minutes long. But that's the basic principle of MapReduce. As it's 10 years old, it used ideas like writing intermediate results out to disk, which is slow because writing anything to a disk mechanical is slow. The hardware requirements, you need a cluster. I am a postman. A postman in English is somebody who delivers letters, but I am post-PC. I am post-Java. I hate Java. It's complicated and difficult. And I am post-von Neumann. The von Neumann architecture has been around for 50 years. It was very successful, but it has passed its sell-by date, and it should be taken out in the pallet and shot. Okay, so I'm a postman. So if you want to be millionaires, you learn the basics of how all these post-PC, post-Java, post-von Neumann ideas work. If you want to learn, Professor Binbrain will run a course, and we're talking about running summer schools and boot camps here in Morocco. So the hardware requirement, Google tells us they need a dual processor machine running a standard Intel processor, commodity. You basically just link all these machines together in a cluster. The Hadoop distributed file system, because you're using thousands of processors with cheap replicated hardware, you will get a failure rate. So, like all distributed processing, the Hadoop distributed file system is designed to cope with failures without interrupting the processing. So, if a processor dies or a disk store dies, there is a replica of it, a copy of it somewhere else, and it just automatically detects the failure and switches over and carries on. You get a blip of a few hundred milliseconds, and then after that the cluster keeps going. The distributed file system has got one very intelligent node, which is called the name node, and then it has data nodes, which basically take a program distributed out to them with a piece of data, and it does what it's told by the name node. It's that simple. Now that hides an awful lot of complexity that will get you at least a master's degree if you write a thesis about it, and maybe a PhD. The improved data formats. The kinds of things that you would store in databases will no longer be the text that we had in all these billing and personnel management databases based on SQL that never changed for the last 30 years, ever since Cobb invented the idea for IBM. All of a sudden, you want to be able to store semi-structured data in JSON files. You want to be able to store videos. You want to be able to store audio and the metadata that goes with it. And you want to be able to store information as RDF triples. Anybody here know what RDF is? 1, 2. Excellent. I'll talk to you later. I'm looking for people who know about RDF because they are really gold-plated. Know about your. I want to know about your company. We might even make an extra. Okay. The kinds of productivity gains that have been achieved over the last 10 years with MapReduce, which is a very simple technique that I described of distributing data out to a node, doing a bit of processing, sending the results back to the central node. They have achieved this kind of productivity gain. Visa processing 73,000 million credit card transactions, which is a month's credit card transaction, went down for processing time of 1 month to 13 minutes. Now that's transformational. That's disruptive. That's the kind of thing Chandan was talking about yesterday. It enables whole new industries because suddenly, from being able to detect card fraud a month after it's happened, you can do it in real time, and you can catch the bad guys in the act. Okay, now that changes the way the world works. Okay, it's like when we saw the first microprocessors come along in the 1980s. 10 years later, we had mobile telephones. We have enabling technology for complete new industries. Now, there are lots and lots of problems with this 10-year-old design. I've already mentioned working with data on disk and intermediate results that you have to write very slowly out to a mechanical disk, and then read back in again and start processing all over again. What Spark does, which is the new version of MapReduce, which you can find out about in this book here. Don't wait for somebody to stand up in front of a class and teach you how to do it with the students. Buy the book. Log on to the site online. You don't even have to wait for the paper book. If you take out a subscription to O'Reilly, you can read the whole thing online, or you can download it and print it out, and it's a lot cheaper. But Spark runs 100 times faster than the basic Hadoop. So if we could reduce a month's work to 13 minutes, by how long do we reduce the processing time if we increase the processing speed by 100? 13 minutes divided 100. Anybody here good at arithmetic? No? Anybody here able to do a division by 100? No? 0.13 minutes. Well done. So less than a fifth of a minute? 10 seconds? Yeah, 6 seconds. So 6 seconds down from a month to 6 seconds, that is totally transformational. There aren't enough people in the world that know how to do this at the moment. The Americans want 150,000 and they'll wave a green card at you. And Europeans will do the same because they need another 150,000 people who know how to do it. And UK is probably the only country in the world that won't give you a visa. Because it might continue immigration policy being talked about. Okay, right. Spark has high performance attitude, high performance characteristics. It's very simple to program. All the parts of Spark use the same. They use the same interface. They use the same programming language. So if you're doing machine learning, if you're querying a database, if you're querying, if you're using the machine learning facility. Okay, because it's got the same interface, you only have to learn one interface, one programming language. It's a very rich programming language, if you can write queries for one part, for SQL queries, you can write queries for the machine learning part, you can write queries for the graph analysis part, you can write queries for the streaming part. Because unlike Hadoop, which is designed to be batch processing, read a file off disk, Spark can analyze data flows in real time. So you can analyze your traffic flow problems in a city. You can analyze your pollution problems in a city from the sensors, which you have used the Arduino processors that you were learning about 2 days ago to have a network of small sensors all around the city. So you can measure the air quality, water quality, and all the rest of the things. And it can be extended, because it's written in Scala, you can write extensions to it, so that if there's a facility which is missing, you can extend it yourself. It all works using directed acyclic graphs. How many people here know about directed acyclic graphs? 1, 2. I want to talk to you about your small company later. Okay, directed acyclic graphs are a new way of thinking of designing programs. It's automatically done for you by Spark, so you get an optimized program which makes it run faster and faster and faster. Now do you see the excitement of knowing about Spark? It's 2 years old, and the number of people who know how to write good programs in it are very limited. So you have the opportunity, same as we did in Cambridge in the 1980s, to make $1 million out of it. All this will be available online later. Spark can be programmed in any of 3 languages because it's originally written in Scala, which runs on the Java virtual machine. I said I'm a post-Java person. I'm a post-Java person because I cannot live with all these import statements and long and complicated statements which make mistakes. The key, yep. Oh, well, C++ multiplies the number of errors in your coding by a factor of ×10 if you choose C++ over a better type language. Java is verbose, and the key to good programming is to simplify the code, because you write it once and you read it many, many times. So if you're modifying code or trying to debug it, a language which is simple and easy to read is far more powerful than this god-awful Java thing. And I said I'm a postman. So there are 2 languages. One is called Python, which I expect everybody knows. How many Python programmers are there in the room? 1? Oh, I want to know about you. I want to know about your company too. Python programmers? Well, if you want to be data scientists, you remember I said we're not going to spoon feed you, we're not going to stand up in front of a class and teach you how to do things. We expect you to go and buy the book, work through the exercises in this book here. If you can make all the exercises in this book work, you can get it online from O'Reilly, or you can buy it from Amazon. If you can make all 25 examples in this book work, you can call yourself a data scientist and you can get yourself a job anywhere in Europe with a salary of £50,000 a year. And then we have Scala. Spark is written in Scala. Scala is no longer an imperative language. Imperative languages are things like BASIC and Fortran and things like that that are designed to work as a single stream of instructions. If you're working across a cluster and you have a loop that says do from 1 to 10, and you have all those activities spread across 10 clusters, if you say count from 1 to 10, you might get back the answer 1, 7, 4, 5, 3, and so on. Unless you have a language which is designed for parallelization. Okay? And this is called functional programming, which is a totally different concept to the ones that we have been learning for the last 20 years. This is what I said. I'm a postman. We've left all that from Neumann stuff behind. If you want to get rich, learn the functional programming stuff. Okay, how do you get started with Spark? Well, you download it off the Spark website. I've done that. I'm not going to show you any examples now because it would take too long. But I've downloaded it onto my PC and I can show you examples at lunchtime. And there's an examples directory, so we can actually run these examples. The simplest one is calculating the value of pi through iterative programming, and there are another 20 examples that you get if you download it from the website. It's a big download and it takes some time to build. You need to have Java 6 or Java 7 installed. And you need one or two other programs, but it installs quite easily. You also need to learn some of the Linux tools. SBT is the simple build tool which is used for building Scala applications. SBT is very straightforward to learn. Again, log onto the website and it teaches you how. Maven is legacy from Java, and basically it's a makefile for Java. And it generates the dependencies and the includes and things like that. It is far more complicated than SBT. Apache Mesos is a cluster manager program. So if you've got 64 or 1,000 processors in your cluster, Mesos will manage that, and it will manage where the files have gone to, and it will manage the backups and resilience and all the rest of it. Uncle Amazon will let you put stuff on the East Cloud on a pay by the volume of data that you use and the time that you use it for, which is great for doing quick, short, dirty prototyping jobs. And also it allows you to turn on very big databases so that if you want to start genomics processing, then you turn on Amazon EC2 and use it for as long as you need to, and then you turn it off again. And Hadoop, which is the commercial name of MapReduce, Hadoop 1 is Hadoop 2 is called Yarn. You can buy a book about it, you can download the information off the internet, or you can go to a summer school or a boot camp or something like that, about it. So, are there any questions so far? L'histoire. Est-ce qu'il y a des questions? Est-ce que tout le monde me comprend? Does everybody understand what I'm saying? Am I talking too fast? Okay, you can always blame my accent. Okay.
I certainly will.
Oh, well, you're from the Yorkshire. Okay, what do you need to build a cluster? Well, we have an IBM cluster here in the university, but what people are doing is they're using Raspberry Pi, which is a single board computer that sells for £35 each, to build a cluster of large numbers of PCs, large numbers of boards. University of Essex have a 64 Raspberry Pi cluster for learning cluster management, which is a very valuable skill because all the programming doesn't work if you don't have the cluster management skills. And if you come to the University of Essex Big Data Summer School, Big Data and Analytics Summer School in August, my friend Adrian is talking about how he's built this 64 board cluster. You can always find the recipe here, and it's a good research project if you want to be academic about it. Now, if you don't like the variant of Linux that the Raspberry Pi runs, you can always use the Ubuntu version. Now, these people offer a university and academic program, so if you twist arms and know the guy from the Fulbright program, you might be able to get a cluster made of these boards for nothing. Hello? Anybody interested in something for nothing? Yeah? Well, these guys have got an academic program where they will give you the boards because they want to know who can program them. Okay, so no promises. I'm just telling you about ideas. Up to you to go away and do things. Right. We talk some technical stuff, and then I'll shut up and sit down. How much time have I got left?
You have to check the time, Frank, because you know that the time that you go to the airport.
Yeah. How much time have I left? Have I got 10 minutes? I still have half an hour. Okay, good now. Okay, the Chandon's on next. Okay, good. Feet well? No questions. Good. Right. I've already said Hadoop 1 is obsolete. Hadoop 2 is called Yarn. There's lots and lots of work has been produced in a horrible language called Pig, which is unmaintainable. And Hive is maintainable, but needs to be modified so it looks like in SQL. Distributed file system is ubiquitous, but Spark extends the database side to include other file systems, so you can take data from any file system. There are 5 types of big databases. Anybody here know the kinds of NoSQL databases? Yes? I hear lots of yeses. Oh, well done, Professor. Lots and lots of people know about NoSQL. Great. Okay, so I don't need to explain all that. Spark Run has got a very well-defined interface with MongoDB, which is a very respectable, very big database, which will get you jobs if you're interested in jobs, and programming it. You can make yourself a small company if you've got the skills. You need to move all this legacy data into big databases. Jamie will talk about how you do that a bit later. Analytics. Chandan will talk about analytics. Data is like gold or like rough diamonds. Have no value. It has no value until the diamonds are polished and the gold is refined. Analytics is the refining of data to extract value. If you know about that, the world is crying out for people and companies who know how to do it. You did say this is an innovation week, so I'm talking about how to be innovative. Okay, Spark is at least 6 aspects to it. I've talked about Spark SQL. I've talked about Spark Streaming. Spark Streaming means that what you do is you take a second's worth of data, or 100 milliseconds worth of data, and you process it as if it was a static lump. So you can start to extract trends and information from it. All these files will be available, but do feel free. I'll give you my best slide for the photographs. Okay. There's a machine learning language which is both extensive and powerful. So it means that you don't have to fight your way through the OR library if you don't want to. However, Spark is extended so that it will work with the existing OR analytics programs from the last 10 years. And we have the most interesting part, which is the GraphX part, which drives a lot of the government and big banking and fraud detection applications, because if you can graph the transactions and the interactions between people, then the crooks just leap past the page. So I've talked about Spark Streaming, I've talked about machine learning. Again, if you want to teach yourself analytics and you've gone and turned yourself into a data scientist using Python, then if you want to do it with Spark, here's the book. And there's the book on programming in Scala if you want to learn how to do it. I mentioned fraud detection. This is about what they call, this is an insurance fraud where people drive into other people's cars and then make outrageous insurance claims for it. But what happens is that you find the same 50 or 60 people making the insurance claims over and over again. And if you graph all the insurance claims in a country, the fraudsters leap out at you. And they sent 60 people to jail in England last year using this technique. So if you know how to do that, you are really gold-plated, because the banks will fall over themselves to try and hire you. Now, you can't all have a cloud, even if it's a cheap one made of 64 Raspberry. You can't all have a cluster if it's made of, even if it's made of cheap Raspberry Pi computers. What should really happen is that we offer you a cloud, an academic cloud in a university, a group of academic clouds all linked together, which covers all the universities in Morocco, or a national cloud. Ken over there knows how to do it because we did a feasibility study on it before coming down here. Parquet is a product which allows you, it's one of the column databases which allows you to insert an extra column in the data so that you can expand all the factors in your data set. And Tableau is a nice, very powerful way of representing your data. The only drawback of Tableau is that it doesn't run under Linux, it runs under Windows. I have been trying to run a completely Windows-free environment for the last 2 years, and unfortunately there are still some products around which only run under Windows and Microsoft. So, that's me finished. Peace a while.